In this problem, I need to verify the identity secant x plus tangent x over secant x minus tangent x equals 1 plus 2 sine x plus sine squared x all over cosine squared x. So I'll start with the left-hand side and change it into the right-hand side. And my reason for doing this is because the left-hand side involves secant and tangent, which I know I can turn into sines and cosines. And so that'll be easier rather than trying to turn sines and cosines into secant and tangent. All right. So I have my left-hand side. I write that out first. And now I'm going to copy that again. There we go. Because I'm going to multiply both the numerator and the denominator by another binomial. So I have a binomial in the top, a binomial in the bottom, and I'm going to multiply those by another binomial. So, and I'm using binomial very loosely, right? Because this is not really a polynomial in the strictest sense, but I just mean that in terms of there's two terms. So, I want to multiply by the conjugate of one of these factors. So I'll multiply by the conjugate of the denominator, and that's what I usually do. I usually go for the conjugate of the denominator, and that way the denominator gets simplified quite a bit, and you'll see how that works in just a second. So I multiply the denominator by secant x minus tangent x, and so to keep this the same, I have to multiply the numerator by the same thing. Okay. So my next step is going to be foiling these together. I'll take the numerator and get secant squared x plus 2 secant x tangent x. Oh, I put a minus here. Let's see, we need those to be pluses because I need this to be the conjugate, right? That means that the signs have to be opposite each other. All right, that's all right. And then we have plus tangent squared x. Okay, and that's all over secant squared x minus tangent squared x. So in the denominator, the middle terms cancel out. All right, so now let's see what we can do with this. Well, in the numerator, I have secant squared x, and I can turn that into 1 over cosine squared x. So I'm turning these into sine and cosine to make them easier to work with. Plus 2 secant x tangent x, so that would be 2 times 1 over cosine x times sine x over cosine x. And then plus tangent squared x, which is sine squared x over cosine squared x. So that's just the numerator. And that's all over, in the denominator, I have secant squared x, which is 1 over cosine squared x. And then that's minus tangent squared x, which is sine squared x over cosine squared x. Now, I have a common denominator. Every term, I have 1, 2, 3, 4, 5. Every term has cosine squared x in the denominator. This one hasn't been multiplied together yet in the middle in the numerator, but as soon as I do that, it's going to be a cosine squared x. So in order to simplify this, what I'll do now is multiply both the numerator and the denominator by cosine squared x over 1. Okay, so now I have in the numerator 1 plus 2 sine x plus sine squared x. Well, that's exactly what we wanted, so that was perfect. And that's all over cosine squared x times 1 over cosine squared x. Well, that just multiplies to make 1. And then I have a minus sine squared x over cosine squared x times cosine squared x. So the cosine squareds cancel out, and I have a minus sine squared x. And 1 minus sine squared x is going to give me cosine squared x. And that's exactly what we were looking for. I made it just in time. I was running out of screen. And so there you go.